Okay, here is a video on how to do a proper projectile motion with the ball moving horizontally and no angle. So as you can see here, a ball is thrown horizontally with a speed of 10 meters per second and 50 meters off of a cliff. The cliff is 50 meters tall. So the best thing to do when you get a problem like this is draw it out. So here we go. We have the cliff right here, and this cliff is 50 meters. And we got a ball, show a ball up here. It's being thrown off the cliff with a velocity of 10 meters per second. And this ball is going to go all the way down over here, and eventually it'll land right here. So what we want to know is how long, so we want to know what time equals, and we want to know how far. So we want to know this distance. So distance equals unknown. So a good way to look at this problem when you first get it is first draw the picture and then realize that this is actually in a graph. So make sure you draw in the graph here. Here's your x and y axis because some is moving vertically and some is moving horizontally. And you have to remember that the vertical and horizontal were completely independent of one another. So x and y are solved completely differently. So the x is going to be the horizontal and y is going to be vertical, and you solve them both differently. In the x-axis, we want to know distance, because the distance right here, as you can see right there, is obviously horizontal, so it's going to go in x. For time, we're actually going to solve that in the y, just because we have enough of the information. So time equals blank. So now you got to start filling in what we know. What do we know about x? Well, we know a little bit. We see that this 10 right here is moving horizontally. So we know that the velocity is equal to 10. We don't really know much else. We're trying to find out what d is. Why? We know a little bit more information. One thing that you may not know we know is we actually know the velocity initial. Because you have to look at everything that's moving vertically, and it starts up here with no force pushing it down, minus acceleration. But velocity, there is none. There is acceleration, which I'll get to in a second. So velocity initial is actually 0, because it starts at 0. There's nothing above or below it. And then, as I just mentioned earlier, we know the acceleration, which is equal to negative 9.81. And yes, that is gravity. We also know the distance, because of that cliff. And the cliff is 50. But in the y, vertically, we're going to put everything as negative, just to make things a little bit simpler. And we want to know time. So what equation do we use? Well, when something starts at 0, you can use this equation. Distance equals velocity initial times by time plus 1/2 acceleration times squared. That's just going to be an equation you're going to have to memorize. So we're solving for the y-axis here, because that's where we had all of our information. Velocity initial we know is 0, and anything times 0 is going to be 0, so that equation's out of there. So let me rewrite this. Distance equals 1/2 acceleration times squared. So now let's start plugging in what we know. Distance, we know is negative 50, equals 1/2. Acceleration is 9.81, that is gravity, times by time squared. So now let's do a little bit of math. What is negative 9.81 times 1/2? Well, if you don't know it off the top of your head, you may have to use a calculator, but it is negative 4.905. So then you bring over that t squared equals negative 50. I'm just trying to get t on its own because we are solving for t. So divide this by negative 4.905. Negative 4.905. Plug this into your calculator, and you will receive the number 10.1937. You may want to just round that to 10.2. So there you go, and it is positive because these two negatives cancel each other out, and this equals t squared. So now we get to take the square root of it so we can get rid of that power, and you receive 3.19 equals t. So now we can go back to our graph and we can figure out or put in that t is equal to 3.19. We can add that over here too, because time is one thing that is constant between vertical and horizontal. We know that. So now, what we don't know is the distance. Well then, the equation distance equals velocity times time will come in handy. Distance, we don't know, and we are solving the x-axis now, because the distance is going to be moving horizontally, therefore it's the x-axis. So distance equals our velocity, which is 10 meters per second, and our time, which is 3.19 seconds. And here you can see that the seconds will cancel it out, and when you multiply those together, you get d equals 31.9. You can see that multiplying it by 10 just moved the x over. So there we go. We know that d is 31.9 meters. There you go. You've just found your time and your distance.